We are now going to explain and demonstrate inverse functions.
Solving for an inverse function lets you go back to the original problem. To identify an inverse function, you'll see a variable, most commonly f, to the power of -1, multiplied by an x in parentheses.
To solve for the inverse of a function, you change f of x to y, then switch x and y in the equation. For example, if you have f of x equals -3x plus 6, you switch the x and y and it will change to x equals -3y plus 6. You then isolate the y to get the inverse function of the original equation. Subtract the 6 from both sides. Finally, you divide each side by -3. The inverse of f of x equals -3x plus 6 is the inverse of f of x equals -1/3 x plus 2.
Here is another example. Here you have f of x equals 6x minus 3. In order to solve for the inverse, you have to switch to x and y. You will get x equals 6y minus 3. Then you will isolate the y or solve for it. Add each side by 3. Here you will have x plus 3 equals 6y. Then you will divide each side by 6. The inverse of f of x equals 6x minus 3 is y equals 1/6x plus half.
Now we will demonstrate how to graph an inverse function. Here we have the points of an original function. -8, 1, -4, 0, 0, 1, 4, 2, and 8, 3.
In order to graph the inverse function, you'll just switch to x and the y. For example, xy is now turned into yx. So for -8, -1, just switch to x and the y, and you'll get -1, -8.
Next, you will change the rest of the points of the original points and graph them. Here you will see the green line, which is the inverse of the black line.
The graph of an inverse is always a reflection over the line y equals x, the red line. The original points reflect over the y equals x line to create the inverse line. We are now going to talk about proving inverses. In order to prove an inverse, a composition must be done. A composition is when you put a function into the other. An example is f of g of x or g of f of x.
Here are some functions. Here's f of x equals 1/4 plus 1, and g of x equals 4x minus 4. In order to do a composition, you insert one into the other. For example, we'll do f of g of x. You'll insert the function of g of x into f of x and get f of g of x equals 1/4 times 4x minus 4 plus 1.
Here are some functions. Here's f of x equals 1/4 x plus 1 and g of x equals 4x minus 4. In order to do a composition, you insert one into the other. For example, we'll do f of g of x. You'll insert the function of g of x into f of x's and get f of x equals 1/4 multiplied by 4x minus 4 plus 1.
In order for two functions to be inverses, the answers of the compositions must be x. We will now solve the previous composition. You would distribute the 1/4 across the 4x minus 4. Combine the like terms. Here we see that it seems that these two functions are inverses, but to fully prove it, we will solve for the other one.
We will now solve for g of f of x. Insert the function of f of x into g of x's. Insert 1/4 x plus 1 into g of x. Now you will distribute the 4 across the 1/4 x plus 1. Combine the like terms. We have now fully proved that these two functions are inverses.
We will now show you the difference between the inverse of a function and the inverse of f of x. The inverse of a function and the inverse of f of x. To get from the original to here, you will switch the x and y variable in the inverse of a function, but the inverse of f of x is completely different. If you are inversing the whole f of x, and the function goes on the bottom like a normal negative inverse. For example, if you are looking for the inverse of 3x plus 3, you get 1/3x plus 3.
That is all we have to say about inverse functions. Thank you for listening.